Okay, so this video is clearly about the angle between vectors formula, and I have it listed. It's right here, and it's basically, it tells you if you have two vectors, let's call this v and that u, it will tell you the angle between them. And this is a formula you could just look up or something. You don't really, I wouldn't need a whole video on it, but I do want to explain why this works because, one of my biggest problems with pre-calc was that it's a lot harder to understand conceptually than algebra 2 and geometry. So I was just kind of plugging stuff into formulas, and that made it kind of boring. It felt like you knew less of what you were doing. So I feel like understanding, maybe not intuitively, but at least understanding algebraically what is going on between these formulas helps. And if not with understanding, at least if you forget the formula at some point, it'll allow you to derive it by yourself. Okay, so basically for this formula, we have these two vectors, right? And maybe I should move these because I don't have to redraw them. All right, oops. There we go. Oops. All right, so this is vector v, vector u. And so, like I said, whenever we add vectors, right, we have to do it from tip to tip, like tail to tip and then tail to tip. But we can't add these two vectors because they don't start from the same spot. But if we made one of these vectors negative, like for example, let's change vector v so that instead of going in this direction, it goes in this direction. Okay, now this is vector v, and now this is negative v, okay? And so we're adding negative v and u. And then we get a third vector like this, right? That starts from the tail of v and ends at the tip of u. And this is just a u minus v. It's just the absolute value of the difference of these two vectors because I could have made u negative. It doesn't matter. But regardless, it's just the difference between those two vectors. Okay. Now we can use law of cosines, which you can look at the proof for that somewhere else if you want to know, or I can make a video on it. But yeah, just law of cosines. So you have that u minus v squared is equal to, it's negative v, but it's just the absolute value, right? Squared plus, like, because it's just magnitudes, right? These lengths of these sides, are the magnitudes of these vectors because they're lengths, right? There's just the lengths of the vectors. Minus 2 cosine, or 2 v u cosine theta. So this is the formula when we put it in law of cosines. Now, we have all of these like magnitudes, and then we're squaring them, and we can't really do anything with this because we don't know how these magnitudes work. But I want to prove to you that having a magnitude of something squared, like the magnitude of vector x squared, is just equal to the dot product of vector x times itself. Why is that? Well, because when you have actually maybe x isn't the best. Yeah, x is definitely not the best term. Let's use like z, okay? So when we have vector z is going to have two components, x and y. And so when we take the dot product of those two components, we're going to get x times x, so x squared, plus y times y, right? Because you take the product of the x components, and then you add to the product of the y components, and that's the dot product. So this is the dot product of, a vector multiplied by itself. It's the product of its x components plus the product of its y components. Now, if you remember, the magnitude of a vector is just the square root of x squared plus y squared, right? If you have a vector from here, this is your vector, the magnitude, this length, is just going to be the hypotenuse of this triangle, which has the lengths of x squared plus y squared. So the magnitude squared is just going to be x squared plus y squared. So we know that since these two are equal, we can rewrite everything here as, a product of the dot product of the dot product of this vector in itself. So we can write this like this. Oops, that should not be a dot, that should be a subtraction. This will probably take up a lot of space and it'll look very confusing, but trust me, it is not as bad as it looks. V dot product V plus U dot product U minus 2, and then this we can't do anything with because it's not a squared magnitude. Okay, so now the dot product is distributive, which is something I think mentioned in the last video. So knowing that we can distribute everything here, and we get U times with the dot product of U minus V U minus V U again plus VV equals, we're just gonna bring all of this down. Sorry you're having to watch me multiply all of this out again and again. And there we go. Okay, and now you can see that like U and VV are on both sides of this equation, which is so nice because now we can just be like, bye-bye, bye-bye. Oh wow, my V's and U's look very similar, but that's a V, that's a U. Okay, and so now we have a negative 2 V U equals negative 2 magnitude of V, and I'm sure you can see what's going to happen now. Cosine theta, the negative 2's cancel out, and you're left with cosine theta equals the dot product of V times U over the magnitude of V times the magnitude of U. And this is the same formula that we started with. So, I hope this was interesting to you, and it was just kind of like a mind-blowing, like, whoa moment. If you've seen this formula before, and even if you haven't, now you know what the formula is. Please remember this, because I've seen it on a lot of tests, and you know why this is the formula.